Hey, this is the first of two videos that are going to be covering section 6.2 in your textbook. In this video, we are going to be looking at how to multiply the rational expressions that we've been working with in this chapter. Thankfully, this is actually going to be pretty simple because the key thing to remember is that rational expressions are just fractions, right? They're complicated looking fractions with a lot more going on than your typical thing, but they are just fractions. And so if you remember how to multiply fractions, you'll be totally fine for how to do this. So if you're good with your factoring and you're good with your fraction work, really there's not going to be a whole lot going on here that you don't already understand. So let's look at just some basic fractions like these, right? Not rational expressions. Well, technically they are rational expressions, but no variables. How do we multiply these things? We've got a little bit of freedom with how we do it, but your best bet typically, most of the time, is going to be to start by simplifying. If you can. You can't always, but you simplify if possible. And so remember, when you're multiplying, and specifically only when you're multiplying, you can simplify any numerator with any denominator. So anything on the top with anything on the bottom. But that's only for multiplication. It's not for adding or subtracting. It's not for division. It's just multiplication. So in this case, I can simplify, let's say, the 8 with the 28 by dividing both of them by 4. I can also simplify the 6 with the 15 by dividing both of them by 3. And so once I've done that, I've got 2 over 5 times 2 over 7. I cannot simplify those 2's because they're both in the numerator, right? So it's got to be something on the top with something on the bottom. Once you've simplified the actual multiplication, it's pretty straightforward. All you do is you multiply the numerators. So multiply everything on the top, and you multiply the denominators. And if you already did all your simplification at the beginning, there won't be any simplification left to do now at the end. But if you didn't, you make sure you simplify. So with these ones, this would just become 2 times 2 over 5 times 7, which is going to get us our final answer of 4 over 35. And so if you fully understand that, you fully understand this entire lesson, right? Because you're just going to be doing the exact same thing, but with some variables thrown in. So let's start by looking at the ones that just have a whole bunch of variables with no adding or subtracting. So that's something like, say, 2x squared over 4y times 3xy to the power of 4 over 8x to the power of 6y. For these ones, it's entirely up to you if you want to start simplifying now. I do find that people tend to mix up the exponents a little bit more if they simplify at the beginning because there is a lot more going on. So for me, I would actually multiply before I simplify, but that's just my personal preference. It's really up to you. So whatever you feel most comfortable with. So if we do these, I'm going to do 2x squared times 3xy to the power of 4 over 4y times 8x to the power of 6y. Remember, exponent laws, when you multiply two powers with the same base, you add. So up top, 2 times 3 is going to get me 6. X squared times x is x cubed. And then the y to the power of 4 is still just there. On the bottom, we've got 32 x to the power of 6. And then y times y is going to get me y squared. Now we can simplify things. So we're going to simplify the 6 and the 32, just like we normally would, just like a fraction. So 6 over 32, those are both divisible by 2, which is going to get me 3 and 16. For the x's, x cubed and x to the power of 6. So remember, I covered this in the last video on simplification. Just subtract the exponents. So 6 minus 3. And then you put whatever extra you have, which in this case is 3, wherever you had more. So we had more x's on the bottom, so those 3 x's are on the bottom. Same for the y's. 4 minus 2 gets us 2, and those 2 y's are going to be up top. We do need to end with NPVs, so we've got x can't be 0, and y can't be 0 because the y's were on the denominator before we canceled them out. Okay, so try doing this one for yourself. Just apply the exact same principles. I would maybe on this one simplify the coefficients before you multiply, just because you're going to get some pretty big numbers otherwise. It is entirely up to you. So go with whatever you feel most comfortable with, but just remember it's typically easier to make things smaller before you make them bigger. But you can kind of mix and match. So for me, I would probably not simplify the variables, but I would probably simplify the coefficients. So pause me here, do this on your own, come back once you're done. Okay, so if I'm simplifying my coefficients here, I can simplify 18 and 9. So if I divide those both by 9, the 18 is going to become a 2, and the 9 is just going to become a 1. And I can also simplify the 10 and the 25. So if I divide those both by 5, the 10 is going to become a 2, and the 25 is going to become a 5. I'm not going to do anything with my variables just yet, so I'm just going to multiply. So up top, 2 times 2 gets me 4. A to the power of 4 times a squared gets me a to the power of 6. Then we've got b to the power of 15 and c to the power of 8. On the bottom, 5 times 1 gets me 5. And then we just have b to the power of 5 and c squared. And so this is now what I'm going to simplify. So the 4 and the 5 I don't really have to do anything with. For the a's, we only have a's up top. For the b's, b to the power of 15 divided by b to the power of 5 gets me b to the power of 10. And those 10 extras are on the top because that's where we had more. And same idea for the c's. We're going to have 6 extra c's also on the top. So the only thing left in our denominator is actually just the 5. For our NPVs, we've got b can't be 0, and we've got c can't be 0. But we actually don't have an NPV for a, because if you look carefully, a was never in the denominator. So we only care about stuff that shows up in the denominator at some point. Okay, so that's what you do when you have just a whole bunch of variables. But when we have actual, binomials and trinomials, things do get a little bit more complicated. So if we had, say, x plus 3 over x squared plus 6x plus 8, and x squared plus 5x plus 6 over 2x squared plus 6x. So let me make something clear. In my course, and really in Pre-Calc 11 in general, you should never be getting anything with an exponent larger than a squared. There will be many, very, very, very rare cases, not including these ones that we saw before. Right? These ones, yes, you can absolutely get larger exponents, but when you're dealing with binomials and trinomials, you shouldn't be getting cubes, you shouldn't be getting powers of 4. If you do, you've messed something up. So, with that being the case, in this one here, we are absolutely not going to multiply these two things. At least not directly. What we are going to do is we are going to start by factoring. You have to factor first here. It's the only way to make this work. So for our first rational expression, the x plus 3 is just an x plus 3. In the denominator, if we factor that, we end up with x plus 4 times x plus 2. And then we factor the second one. So if you multiply to 6, add to 5, that's going to get you x plus 3 times x plus 2. In the bottom right, we can take out a common factor of 2x there, which is going to leave me with x plus 3. So you can absolutely just start canceling stuff here. Just remember it's anything in a numerator with anything in a denominator. You could also put these all together in one fraction first, and so have this as x plus 3 times x plus 3 times x plus 2 over 2x times x plus 4 times x plus 2 times x plus 3. So I typically myself wouldn't actually normally do this step just because it's basically just rewriting everything out to no benefit. But if you want to organize things, you absolutely can do this. So if we're going to cancel some stuff out, we've got x plus 3's that are going to go away. We've also got x plus 2's. One thing to keep in mind, we have 2 x plus 3's on top and 1 x plus 3 on the bottom. So that 1 x plus 3 on the bottom isn't going to cancel out 2 things on the top. It's 1 for 1. So don't cancel out extra things that don't cancel. So once we have factored and canceled and put everything together, we're left with x plus 3 over 2x times x plus 4. Don't feel obligated to re-multiply out the denominator here. There are some people who will do it, but by and large, since my focus isn't really just on your foiling or distributing skills, it's not something I'm typically going to expect you to do unless there's a purpose to it. We do still need NPVs though. So at the end of this, we've got a bunch. Our NPVs are x cannot be 0, -4, -2, or -3, which we can get just from all of our factors here from before we canceled things out. All right, and we're just going to actually do one more of these. We're going to keep this video short because there's not really much else to this. So this last one is going to be for you to do on your own. So we got x squared minus 2x minus 15 over x squared plus 10x plus 24 times x squared minus 4x minus 32 over 2x squared minus 11x plus 5. So go ahead, factor, cancel things out, get yourself a final answer, find some NPVs, and then come take a look at what we've got once you're done. All right, so going really quickly through the factoring. In the first one, you should have ended up with x minus 5 times x plus 3 over x plus 6 times x plus 4. And so in that first one, nothing's going to cancel. Sometimes you'll be able to cancel out things within just one specific fraction, but not always. In the second one, we've got x minus 8 times x plus 4 over 2x minus 1 times x minus 5. So if we start canceling things out, we've got some x plus 4s that are going to go away. We've also got some x minus 5s that are going to go away. And what we're left with, as we put these things together into one fraction, so we're doing the multiplication at this point without actually multiplying, we end up with x plus 3 times x minus 8 over x plus 6 times 2x minus 1. And there we go. So that one has been factored. It has been multiplied. It just needs some NPVs. So we've got x cannot be -6, -4, +5, or 1 over 2. And that's multiplication. So really, it's just knowing how to multiply fractions and knowing how to factor. If you can get those two things down, this shouldn't be too much of a challenge for you. In the next video, I'm going to go over division, which you can probably guess is also going to be pretty similar to dividing fractions. So once you're ready for that, go ahead and check that video out.